What if I told you that the largest structures in our entire universe, the huge web of galaxies, those massive voids of empty space, what if I told you they aren't just like music, but that they are, in a very real mathematical sense, a piece of frozen music? That the whole cosmos is basically a fossilized echo of a sound that filled the universe right at the dawn of time. I know, it sounds like poetry, right? But according to a new physics paper, it's a cold, hard, scientific fact.
Okay, let's just dive right into this, because this is where things get truly wild. The paper makes this incredible claim right up front. It says, and I'm quoting here, "This is not an analogy, but an exact mathematical identity." The authors are being super clear. They're not just using a helpful metaphor to explain something complicated. No, they're saying the physics is literally the same.
So what is this identity they're talking about? Well, on one hand, you've got something we all kind of get, sound in a room. Pressure waves are bouncing all over the place, creating these resonant frequencies and stable patterns we call standing waves. It's exactly how a musical instrument works. Now, on the other hand, you've got matter in the cosmos. And what this paper proves is that the very same wave equation, the same math that describes sound in a box, also describes how density waves created the entire large-scale structure of our universe. It's a connection that is just completely mind-blowing. So, to really wrap our heads around this, we first need to look at the mystery scientists we're trying to solve in the first place, which is, why does the universe look the way it does? Why isn't it just a uniform smear of stuff?
You see, when you zoom way out and look at the universe on the biggest scales, it is not random at all. Galaxies aren't just sprinkled around like salt. They form this absolutely beautiful, intricate, web-like structure. You've got these dense knots called clusters, and they're connected by these long bridges of galaxies called filaments. And all of that surrounds these enormous, nearly empty regions we call voids. Even the leftover heat from the Big Bang itself, the cosmic microwave background, isn't perfectly smooth. It has these very specific patterns baked right into it. There's a cosmic blueprint here, and it needs an explanation.
And that leads us to the central question this paper is trying to answer. What is the physical origin of this cosmic structure? This is where the detective story really kicks off, and it turns out the clues are hidden in the very first moments of time.
The answer takes us way back, all the way to the beginning, about 380,000 years after the Big Bang, to a time when the universe was a profoundly different and actually much simpler place.
Back then, there were no stars, no galaxies. The whole universe was basically one unified thing, a super hot, incredibly dense plasma. The paper calls it a photon-baryon fluid. Just try to imagine a soup where particles of light, photons, and particles of normal matter, baryons, were so hot and smashed together so tightly that they acted like a single fluid. Light was literally trapped inside matter.
Now, inside this primordial fluid, a kind of cosmic tug-of-war started up. You had these tiny, random fluctuations in density. Some spots were just a teensy bit denser than others. So gravity, doing what gravity does, starts pulling more stuff into these denser regions. But as that fluid compresses, it gets hotter and hotter, and the pressure from all those trapped photons becomes immense, pushing everything back out again. This constant cycle, gravity pulling in, light pressure pushing out, over and over and over, created gigantic pressure waves. And what is a pressure wave traveling through a fluid? It's sound. The early universe was literally ringing with these colossal sound waves.
But here's the thing. This wasn't just random noise. These cosmic waves had a very specific, predictable structure, almost like notes in a song.
Why? Well, because the sound couldn't just travel on forever. The waves were contained inside a sort of box, and that box was defined by how far a sound could have possibly traveled from the very beginning of the universe up until that moment. This cosmic limit is called the sound horizon, and it basically created a finite space for the sound to resonate in, just like the body of a violin.
And just like any musical instrument, this cosmic violin could only sustain certain specific frequencies or notes. They're called eigenmodes or standing waves. I mean, think about a guitar string. When you pluck it, it doesn't just vibrate randomly, right? It vibrates at a fundamental frequency and a whole series of harmonics. The early universe was exactly the same. It had a fundamental note and a predictable set of cosmic overtones.
And get this, we can actually calculate the size of this cosmic instrument. The paper shows that the sound horizon, the size of that box, was about 147 megaparsecs across. That is almost 500 million light years. This incredible scale is what directly determines the wavelength of the universe's fundamental note. So, here's the really crucial part. This isn't just a cool story. It's a testable scientific theory. If it's right, we can use the math from the paper to calculate exactly what those ancient notes should be, and then we can look for their echoes in the sky today.
This is really the moment of truth for any theory like this. Does the predicted cosmic music actually match what our telescopes can see out there in the real world? And the payoff is just astonishing. The answer is a huge, definitive yes. The theory predicts exactly where we should see peaks of intensity in the cosmic microwave background, and the predictions for the first, second, and third peaks match observations from the Planck satellite with less than 0.5% of error. It is an absolutely perfect match.
But it doesn't stop there. The theory also predicts that the fundamental wavelength of that primordial sound should be stamped onto the way galaxies are distributed today. This feature is called the Baryon Acoustic Oscillation, or BAO scale. The theory says it should be about 147 megaparsecs. So what do we actually observe? Around 150 megaparsecs. That's a match to within 2%. It's just uncanny.
The conclusion here is pretty much inescapable. The math works. The predictions are confirmed by what we see. The universe's large-scale structure is, without a doubt, the direct result of these ancient primordial sound waves.
Okay, so this all builds to the final, really profound conclusion. We've established the sound was there, we've established the math checks out. But how did that ancient sound become the physical structure we see all around us today?
The key to the whole thing is something called a nodal structure. Any standing wave has a physical pattern. It has points of maximum vibration, which we call antinodes, and it has points of zero vibration, called nodes. So when the universe finally cooled down enough for atoms to form, the light pressure just vanished, and these sound waves essentially froze right where they were, leaving behind this physical template. And this is the final, beautiful connection. The minima of those frozen waves, the nodes, the quiet spots where matter was thinnest. Those became the seeds for the great cosmic voids. The maxima of the waves, the antinodes, the loud spots where matter was most compressed, those seeded the formation of today's massive galaxy clusters. And the areas with the steepest change between them, the gradient maxima, they formed the long filaments connecting everything. The cosmic web that we see today is the fossilized nodal structure of that ancient sound.
The paper's conclusion really says it all. Cosmic structure formation is fundamentally a wave mechanical phenomenon. So it's not just gravity randomly pulling things together. The universe's grand architecture was actually predetermined by the simple, elegant mathematics of waves in a box, a kind of fossilized music.
So we're left with this absolutely incredible thought. If the largest and most magnificent structures in our universe are nothing more than a fossil of ancient sound, what other cosmic secrets are out there, written in the language of waves just waiting for us to finally learn how to listen?